All right. Hopefully you hear me now. All
Yep.
right. So yes, today I'm going to talk about a topic that uh, is kind of an assumption that I've run into in quite a few engagements that I've worked on, um, and that is the assumption that writing a bunch of UI tests will be able to catch all the bugs and make sure we're meeting all of our requirements, whatever that means at that engagement.
Steven, let me just
Uh,
pause you there for a second. I don't think you're sharing your slides.
is it not sure?
I did see a slide that said about me.
Yeah.
Oh, there we go.
So,
And I will stop here, actually. Why don't you try that one more time?
okay.
There we go.
You see about me?
Yep.
Okay. Yeah. So about me, Stephen Kilborn. I've worked, and I started my career as actually a systems engineer, working in the Defense Department, really trying to integrate and test software and hardware. And then about 10 years ago, I transitioned more into the web development space, where I've worked as a Scrum Master, product owner, and a tester of some sort. I've done both automation and manual testing. I really love playing with different automated tools like Selenium, Appium, Cypress, Playwright, whatever the flavor of the month is. It's fun to try it out, see how it works. But really, my passion in all of this is trying to help teams quickly ship a quality product. So when I come into engagements, a lot of times there's this assumption that, hey, you know how to write automated tests. You need to start writing tests to verify everything. And I want to fight back with that and kind of say, well, let's break this down into two questions. One is, are UI tests the best way to verify everything? And is there a way that, hey, we can actually reduce our risk before testing? So my proposal and my assumption that I want to try to get across to people is that UI-based end-to-end tests for mobile and web apps do provide value. But they're best used as part of what I call a holistic risk reduction strategy. They should be a supplement to our team's collaboration, and they should be used sparingly. So a little roadmap for how I will get to that conclusion. First, I'm going to stop and kind of give a real high-level intro to UI-based end-to-end tests. I don't want to assume everyone knows what I mean by that or how they work. Then once we kind of have an idea of what these types of tests are, I want to take another step back and say, like, why are we even writing tests? Why are we even testing? It doesn't have to even be writing tests. It can be manual tests. And then I want to introduce this concept of a holistic risk reduction strategy. So that high level, I'm not going to get into the specifics of what Selenium does versus Cypress or anything like that. Lots of great resources out there. But I want to go with this talk of, I think a lot of people just hear you're going to write automated tests and they're like, okay, you're creating robotic users. And I think, yes and no. I think you really need to know a little bit more detail than that, even if you're never actually writing these tests. So how these work is a developer writes code to look for elements on a page. And I'll go into a little more detail on what that means. Once that element is found, the code somehow interacts with it. It may execute a click, or it may send some keys to an input. And then once you have all these, the ability to find an element and interact with it, you start kind of puzzle piecing a flow or simulating a user journey to try and verify that that functionality that you care about works the way that you intend. So finding elements, you'll see here in the black, a button. There are a few different ways that are common to do it. Probably the most common is XPath. And XPath, it looks like a bunch of gibberish, but it's essentially a path going down through the DOM, the object model of the website, showing where that button is in this case, or a CSS selector, which those are a little bit more based on the class or the ID, but very similarly looking at the code. And then some newer packages have things like find by role, where you can look for any element. It could actually be a div, but it's been assigned the role of a button. And in this case, it's looking for something that has the role of a button that's named submit. So this is great, but it's imprecise, and there's a few reasons. One is that slow loading elements cause failures. That's probably the biggest reason for flaky tests. If you go on Google and say like flaky Selenium tests, they're going to have run into how to deal with slow loading things. Sometimes everything works great when you write a test locally, but once you introduce network delays, it takes fractions of a second longer and your code looks for something that's not there. Another thing, especially with XPath, is that you can be great for one release and then you go add a new button on the page or something like that. And now the locator is different. And either there's two scenarios you can have. One, it's just can't find the button that you had been doing and test immediately breaks. Another is you're clicking on a different button. And I've seen tests that actually still pass because they relied on XPath and they magically worked, but it was testing something completely new. So that's not giving you a lot of faith in how that test was written. And then another thing is unintended layout changes won't necessarily be caught. So that button may have shifted and it's overlapping with an image and doesn't look quite right, but the locator still the same. So the test works as planned and no one really catches it until you somehow visually look at what's going on. All of these kind of boil down to the idea that these end-to-end tests aren't really how a real user interacts with a page. There are also some other challenges, even if you're able to work around all of that. One is that end-to-end tests are slow to run. And I know that sounds kind of crazy if you've ever run a Selenium test. It looks blazing fast compared to you navigating a website on your own. But once you start taking 20 seconds to go through a flow and you have a lot of flows in your site, that 20 times 200 or 400 really starts to add up. And it can take a while to actually get some feedback on if something worked or did not work. The other idea is that that with complex test environments really make it hard to really do these tests. So what I'm saying, at one point in time, it's pretty common just that you'd have something like a JavaScript-based front end and maybe an API hitting a single backend service. But that's very rare these days. I don't think many of us work on that simple of a site. You're going to have a lot of microservices that talk to each other, probably throw in some third-party dependencies. And all of these things take time to either spin up a test environment that needs to be somewhat similar to your production to give you good confidence, or you're faking things and you don't really simulate an end-to-end test. And then probably the biggest thing, a lot of these tests, because it is complex to spin up everything, and then it takes a lot of time to run. Some organizations don't even run tests immediately on a PR being opened. They might run their whole suite every night. So it might be the next day before a developer learns that, hey, that feature you thought you were done with actually caused a regression. You need to drop this new story you'd picked up, go figure out what broke, fix that, and then you can come back. And you're introducing a lot of context switching. So there's problems, and then there's also things they can't catch. One of those is visual defects. I mentioned that earlier, like a button could shift and be overlapping something, and end-to-end tests can't catch that. You need human eyes, or you need something like Applitools or Percy to introduce one more type of testing to actually catch some of these visual defects. The other is there can be unexplored edge cases. You can only write tests for the edge cases you're thinking about. So if you're going in and just writing tests for one thing, no one stops to ask what happens when you go down this rabbit hole. Stuff can slip through. And then I think the biggest thing is misunderstood requirements. A lot of times you'll have a developer think they understand what's being asked for in the story. They develop it. They think it's good. And a lot of times that a tester goes in, looks at it, and yeah, that makes sense to me. And then product owner gets it, looks at it like, wait, this wasn't what I expected. Somewhere in there, stuff got lost in translation. And if you have end-to-end tests validating what the developer and tester assumed, your tests aren't doing you any good because they were validating something that was a misunderstood requirement. So knowing those issues with end-to-end tests, let's step back for part 2 here on why do we actually test? And I think there are 3 real reasons why we do any testing here. One is to provide confidence in what we deliver to an end user. The end user is really the only person that can say what makes the product a quality product. And we have some ideas that we are handing off to them. And we want to be as confident as possible that what change that we intended to make gets to that end user and that we didn't break something somewhere else. The second thing is to provide fast, accurate, reliable, and predictable feedback. I think we've all heard or seen these testing suites and 95% of them always pass, but there's 5% that may or may not work. And that doesn't give you any confidence because if you're just going to roll the dice until you get everything green, or it's probably a bad test, let's just go ahead and manually test it anyway, that test really isn't doing you any good. And then third, I think it's going to make maintenance easy. If I get a request to go add a feature on one page, I want to very quickly know, does that cause a regression elsewhere? And a good testing strategy is going to provide very clear feedback. So I know like, okay, this changed what I intended and didn't break something somewhere else. All of these really boil down to the idea that we want our tests to allow us to very quickly ship a quality product. So instead of trying to rely on just end-to-end tests, I think there's a better idea that I call a holistic risk reduction strategy. This example that I'm going to put together is JavaScript based because that's where I'm the most comfortable. I can do front-end development there. I can do a little Node. So I know the tools, and that's where I've worked the most. I'm not saying these tools that I'm putting forward are the only tools or the best tools, but I'm giving examples of how you can work into a holistic strategy. So I think you should start leveraging static testing. You should test throughout the application stack. You should test the contracts between the consumers and the clients. You should minimize feedback loops with frequent conversations, and then sparingly use end-to-end tests. So let's dig into what each of these bullet points means. So step 1, leverage static testing. Static tests allow you to test without actually running the code. In the JavaScript world, you have the idea of a style guide like Prettier. That makes code reviews a lot easier because in JavaScript, you can do a lot of things with spaces and semicolons that really are up to style preference of the user. And they're all good syntax, but some make it easier to recode than others. Linting is a ability to actually look for syntax errors. And without actually running the code, it can catch and even fix the errors. And then type checking is the idea, like in TypeScript, of checking to see, like, maybe you accidentally passed a number instead of a UUID, and that's going to blow up somewhere in the code. And it can catch that before you actually run the code and get to a scenario that accidentally passes that. So seeing this example here on the right, I've defined a constant A and then constant AA. They both do some stuff looking at some ors and ands. So it's a little hard to read. And then there's also a function here called 10 hello that based on the name, you might figure out, okay, it's a for loop and it's intended to console log out hello 10 times. So looking that way, if I just run these static tests, really on save, I can change the code to make it a lot easier to read. Suddenly I have these parentheses, so I can see like, hey, if B is true, A is always going to be true. If B and C is true, then AA becomes true. And it was probably hard to pick up in the first slide, but in that for loop, I had I is greater than 10 instead of I is less than 10. So I would have had this infinite loop that kept going and blew up if I tried running the code. So comparing very quickly makes it a lot easier to read your code consistently. It makes your reviewing your pull requests a lot quicker, a lot more consistent. And you're not having to do a lot of work once you've actually installed these packages. So the next step is the idea of testing throughout the stack. I think most of us are familiar with the idea of unit tests. It's not a new concept by any means, but for thoroughness sake, it is the idea of taking a small chunk of code. You can argue what a unit is, but it's something small. And you verify that for the inputs that you give it, you get expected outputs. Traditionally, this is very heavily used in the back end, and in the front end, there tends to be this idea of business logic being tested. But really, we have newer tools in JavaScript world, like testing library, that lets us expand and get be a little bit more thorough in our testing. So they have this philosophy with testing library that's the more your test resembles the way your software is used, the more confidence they can give you. So they're really pushing to get developers, instead of just testing what they would have considered business logic, which often gets into the weeds of implementation details. So testing, did a function get called versus what the user wants to happen? They're giving you tools to really test like a user would be using it. So in this case is a form, and that's allowing you to test this form very thoroughly. So if you have on the left some code for this form, so it's like a input that's called email. It has a label that's email address. Below that, you have an input that's called password, labeled password, and then a submit button. On the right, you'll see a very basic test using this library. And what's nice about this library is it is actually looking for an input that has a label of email address, and then another, and actually typing in an email to that. And then it's looking for an input called password and typing a secret password there. And then it's clicking on a button that has a role of submit. So that's very much like how a user would be using it. I don't go to a website and look for an XPath. I don't go and look for what has the class name of email. I look for a label, something that's labeled email address and something labeled password. A bonus for this is if for some reason a developer forgets to tie the label to the input, this test is going to fail. And that's something that's required for accessibility. So you get kind of two birds with one stone with this type of testing. I'm then able to call a function and verify that the function is actually using the email and password that I expected. So using your available tools for unit testing, back end and front end, and using static testing throughout of that, you're starting to get a little bit more holistic idea of reducing the risk. But I think we've all been in that situation where you have a really thoroughly tested back end or microservice, and then you try tying it to the next piece, the next front end, or another microservice. And that's also working exactly like you expected. And somehow wires are crossed and it didn't very easily integrate. So there's a way to make that a lot easier. And that's this idea of consumer-driven contract testing. So before we get into exactly how that test works, I'll define some terms. So consumers make requests. They consume information that they request. So if we have a very simple website that's a React or Vue front end, it's going to be the consumer. The provider is providing the response. So if you make an API call to a service that gives you back some data, that's the provider. So consumer-driven contact tests help us verify that the provider, that is the backend, knows what request a consumer is going to make. So it might say, get all songs. And that the provider knows how to provide that response in the format the consumer expects. So let's look at that in a little bit more detail. Well, comparing before I go there. End-to-end tests versus contract testing. End-to-end tests is going to spin up a full front-end service and a full back-end service. And then you're going to actually, like a robotic user, more or less, try to display on your site all those songs from a get all songs. The contract test is going to provide us a way to verify that this interaction should work without spinning everything up. And then it's to give that example now of how that actually works. The consumer is going to register some interactions that it's expecting to receive from the provider. So I know this is a lot in a short presentation, but on the right, you'll see some code that's really spelling out a method of get, and I'm not sure if my mouse is, nope, but you'll see a method of get there and trying to get songs. And the consumer is expecting a 200 response when it calls there. And each song should be an object that has something like an ID, a name that's a string, and a year that's a number. And if you have other information, the consumer doesn't care. So consumer generates a contract like that, and then it uploads all that information to a broker. That broker is kind of like a database that's holding all these contracts. So there may be a website version of your app, and there may be a mobile app. And the mobile may have different requirements. It may have a like a mood that you want to tag for every song, but that it really needs to display and work, but the website didn't. So the provider is actually going to go see every contract for every consumer of its information, and then it's going to verify that it's meeting all of those expectations. So it'll pull out both, and if it meets both contracts, then it can deploy. If not, you're going to get some red flags and say, hey, you can satisfy the website, but not the mobile app. We need to fix things. So that tooling allows you to start having those conversations instead of you deploy and you having to run all these smoke tests and see like, okay, the website's good, but now the mobile app is broken. So we're getting a lot more confidence when we deploy and make changes, but there's still this idea of what happens if we misunderstood requirements. And really, in my experience and all my engagements, this is where most bugs and most problems pop up, misunderstood requirements. And I think the solution to that is not going to be some type of tool. It's actually going to take some intentional work to have more conversations. Traditionally, conversations are very limited. You have some sort of requirements gathering or backlog grooming where you put together a to-do list of acceptance criteria for each story. Maybe your team does BDD formulation. You have your three amigos get together and they put together what's expected, but then they don't really talk that much once the feature work's going on. It seems very common to put together that acceptance criteria on a story and the developer picks it up. Nothing happens until somehow or another, someone starts testing it after it's supposedly done. And then you have this big feedback loop of, that's not what I expected, or you misunderstood me. And that always turns into either bugs or completely rejecting the story. And that story you thought was going to be done in 2 days turns into 3 or 7 or a nightmare. So I think it's very important to increase conversation points. And some places that you can do that is that continue having them during those requirement gathering. I think it's very important to have this idea of a story kickoff. So you may do the requirement gathering and backlog grooming and then start a sprint. And during the second week of the sprint, the developer starts work on a story. At that point, have a conversation and make sure there's no information that's changed, that the developer, your tester, the product owner, and hopefully even design could be there, making sure that the requirements and nothing's changed now that you're looking at the code and actually about to start the work. And then another thing is make it very open and free to ask questions during development. In some atmospheres, it can be adversarial. Or a developer feels like he'd seem inferior if he asks questions. He just wants to go there and look like he knows what he's doing. But really step in there as a quality engineer or someone at this conference. Take it upon yourself to say like, hey, how's it going? In a friendly manner, not in a judging manner, to really look for ways to make sure that the developer is not struggling or not confused on that story. And then as a team, work to have code reviews and demo the actual work. Don't just look at a PR and say, yeah, it looks right. That's what I expected. And don't just hand it off to a tester or quality engineer and wait for them to test it. But try and walk through it together. Look at some of the edge cases. Was that what everyone had agreed on beforehand? And then during feature integration, all this is great, but I think there's always going to be some need to have some exploratory testing. We're getting more and more technologies that throw in AI and look through paths that you didn't think about. But I think whether it's a dedicated tester, whether it's the developer himself, I don't think that really matters. I think what really matters is a human kind of walk through your app and does that really feel like what you wanted to give your end users? So I think the big benefits of these conversations is that you're able to consider edge cases early. You're able to have those conversations during backlog grooming, again, during that story kickoff, when you're looking at code and like, this is the actual file I plan to change. Was there something we didn't think about? You're able to discover misrequirements. Hey, when we wrote this story, we assumed the user could only be this role, but actually there are some edge cases where a user can be this role and this role. How do we want to cover that? And then you're also able to share context. That's great for both onboarding new members to make it easier for them to get up to speed. And you may have someone that's working on a seemingly unrelated component that's able to bring some insight into how things work as a system. Once you've done all these other 4 steps, I think then you can sparingly use end-to-end test. So the key to end-to-end test is a test flows to verify connectivity between components. So look at the different components in your system. If you have a lot of microservices that only get hit for one flow, make sure you're going through that. And big things that this can catch is stuff like environmental variables not being in place. It looks like it's deployed, your uptime monitoring is great, but something's not quite right. And most importantly, validate that what you're putting out there expecting an end user to be able to accomplish is something they really can't accomplish right now. The big thing is don't try to validate every acceptance criteria that can be validated elsewhere. If you can check something with a unit test, do it there. That's going to give you very quick feedback, very low-hanging fruit for catching something before it gets deployed and not waiting for a day or two for some sort of end-to-end test suite to catch up. So in conclusion, I think end-to-end tests are great. They're really fun to write when you can get it to work. They're very fun to watch, but they're not the best way to assure that you are minimizing the risk for everything in your system. The real key is to look at it as like an onion. Test as often as possible. Have conversations both within your component and between components, and make that the crowning thing of what you're doing. Don't make the UI-based end-to-end test the peak of your pyramid. Make that conversations be the peak of your pyramid. Thank you. That was my last slide. If you have any questions, feel free to reach out here.
Yeah. Thanks for that talk, Stephen. Very insightful. I really enjoyed the concept of the holistic risks reduction strategy. To kick it off here, we've got, I think, about 7 minutes for questions. So Jessica had a question. How can you foster open dialogue between devs and the rest of the team if the developer is a third-party vendor under contract?
It can be tough, especially once you throw in the fact that sometimes they're even like offshore, so they can feel like they are very expendable. I think the best tactic is trying to make sure that you're not coming in there portraying yourself as if you're someone that's a tester. Don't go in there portraying like, hey, you screwed up. Explain what you're doing, explain what your goal is, and say like, hey, I think this was something that a user is going to catch, and we missed that in the requirements, and kind of take it on, because you should be involved in the requirements gathering. So if it's something they messed up that was missed on the requirements gathering, kind of own it yourself instead of saying, hey, you screwed up. Have a little bit of that humility, and so it's not very accusatory. And some ways, like, be gracious of like, there's going to be cultural differences in those scenarios as well of, hey, I don't really understand why you're upset, but this is what we need. And try to be understanding of why they might be upset.
All right. Let's see, we've got a couple more here. From Laura, she says, if your organization already has an over-reliance on E2E unit tests, how do you begin transitioning away from that?
It can be tricky because I think the key is looking, are those tests really providing value right now? And it might not be the best solution, but sometimes you have a really large suite that is the only thing that's sparing you from spending 12 hours every day walking through everything in the app manually. So if that's the case, where they are providing value and they're just not the quickest way, I think the key is look for parts of the app that you can start adding unit tests, and then check away. Maybe a common thing, or like password validation. It's like the go-to Selenium test. You don't really need a Selenium test that will validate all the different scenarios for password inputs. That's probably a good way that you could look, because the client on the server side that's being validated, look to see if that validation is happening there, and can you put some unit tests on the server to validate that. And then once that's working, kill off those unneeded tests and do something like that. Just look for where you can start adding value on existing code as a unit test, and then back away, because you need the unit test as that foundation of your testing pyramid. And then you can start thinking about, here's ways I can do more contract testing or stuff like that.
Great. Speaking of unit tests, you had mentioned the testing library.
Yes.
So is that a framework, or is that, it seemed like it was a unit testing tool, but also had a UI testing component? Could you talk a little bit more about that?
Yeah, so it was a package created by Kent C. Dodds originally. So there are now versions for React, Vue. You can actually use it for Cypress and WebDriver IO. But basically, it kind of wraps your tests in React with the ability to interact and look for buttons, and it kind of restricts you in ways that you can look for elements. It's not rendering a full page in your React test or your Vue test. It's rendering the DOM. So it's essentially, you can actually show it on the command line, and you can see like the whole DOM rendered out there of what's going on if you're trying to debug it. And you're going to see what looks like, to paint a mental image here, it looks like code of what a button would look like. And it will interact with that button. So if there's a button that matches what you're looking for, it will fire the interaction of clicking it. And you can simulate without spinning up a browser or without spinning up a full backend for that to talk to.
Great. I look forward to playing with that a little more. I think we have time for one more question. If there's anyone in the audience who has a question. Let's see. I guess not. I have just one final question. You talked about that story kickoff meeting. Just curious. I think that's one thing that is always hard to do, just because you're starting your sprint and you're trying to get going with things, and sort of developers go their way, testers go their way. So, in your opinion, should that kickoff meeting should it be a formal thing or an informal thing? What might work best?
I think what works best is a very short time boxed 10 or 15 minutes informal meeting. I've had the most success in it in a in-person environment. I don't think the world really does that anymore. So it's a little harder to get buy-in for some people because it feels like one more Zoom call to jump on. But if you can do it, even if it's just via Slack or Teams or whatever your instant messenger is, and just like have some questions like informally, like, okay, have you thought through how you would test this? Do you understand the requirements? And very quickly, because if you take more than 10 minutes, that means there's probably something wrong with how you defined the story. And you probably need to spend some more time grooming it or breaking it down because it's more complex than it needs to be.